Very good morning, dear student. Welcome to the SUTHAR'S class. Dear student, today we are taking the exercise of NCERT book 6.2, that is very important, which is related to the basic proportionality theorem. So dear student, we have already learned what is the basic proportionality theorem, and here we have to use the result of the basic proportionality theorem. So dear student, the basic proportionality theorem states that if in a triangle, if we are drawing one line parallel to one side of a triangle, then it will intersect other two sides in the same ratio. So that we have to use this result. So here question what says, in the given figure there are two figures, triangle in 1 and 2. So what says? DE parallel to BC. In both triangle, DE parallel to BC. As we are also given the measurement of some part of the sides or sides are given, then you have to find EC in the first problem. You have to find the length of BC, and in second AD you have to find. So by using the basic proportionality theorem, we can find these values. So as given, you may write here as given in triangle ABC, DE parallel to BC. So now by the basic proportionality theorem, if this is, then by basic proportionality theorem, I am writing short name, that is BPT. So what says basic proportionality theorem? If DE parallel to BC, then AD upon BD is equal to AE upon EC. This is the result of the basic proportionality theorem. Now put the given value. AD is 1.5 here. So for 1, AD is given as 1.5 and BD 3, AE 1 and EC we have to find. So cross multiply, EC equal to 1 into 3 by 1.5. So this is 30. So we get the AC equal to 2 centimeters. So this is the answer, very simple. Similarly, you consider the second. For second, you can see here this also same result is there. DE parallel given BC. So again you have AD upon BD equal to AE upon EC. So same value you put AD upon BD equal to AE upon EC. Here also as you may write DE parallel to BC and by BPT. We get this. Now put the values. AD we want to find. BD is here given 7.2 centimeter. AE 1.8 and EC 5.4. So see here AD upon 7.2. This is 18 upon 54 point. Remove with the point. So cross multiply. AD is equal to 18 upon 54 into 7.2. So you can divide by 9 2 times, 9 6 6.7 6 7 are. So this is 0.1 and 2. So 2 into 1.2, that is 2.4 centimeters. So in this way you can find the length of AD, or here AD is, hence AD equal to 2.4 centimeter. So in this way, using the basic proportionality theorem, we can find the length of the figure. Now next is, so dear student, question number 2 C. E and F are points on the sides PQ and PR respectively of triangle PQR. It means we are given a triangle PQR. This is the triangle QR. So what problem says? E and F. E and F are points on the sides PQ and PR. We join EF. E and F are points on the side PQ and PR, respectively of triangle PQR. For each of the following cases, state whether you have to do that. Check that EF parallel to this EF is parallel to QR or not. That we have to check. Now there are three parts. In different case, we are given the length. So you have to check either the ratio, because to prove this line EF parallel to QR, it means we have to check the ratio, right? So if you see the ratio is proportional, then by converse of BPT, we can say that EF is parallel to QR. So how to check the ratio? That will be according to the given size. Suppose PA is given here. Means this is given, EQ is also given, PF is also given, and FR is also. All four parts are given. So you can find the ratio like PE upon EQ. That is 3.9 divided by 3. So you can divide 1.3. And if you find the ratio of PF upon FR, so 3.6 divided by 2.4. So 36 upon 24 divided by 6 or 12, 3 by 2. So what we see that this ratio is not equal. So here ratio of this side 1.3, here 3 by 2. So 1.3 is 13 by 10, which is not equal to. So by 1 and 2, by 1 and 2, we get PE upon EQ is not equal to PF upon FR. So by converse of BPT, this is not parallel. Correct? So EF is not parallel to. So we can say here EF is not parallel to QR, because our target is we have to identify this one. If this ratio is equal, then by converse of BPT we say this is a parallel. Otherwise, not. Clear? Similarly, second say PE is given. Now we are given QE. Clear? And EF and again RF. All four same side are given different measurement. So here again we have to find the ratio PE upon QE. That is 4 upon 4.5. That is here we remove 40 divided by 5, 8 and 9. And PF divided by RF, that is 8.5 divided by 9. So if you remove this is 90. So again divide by 5, 1, 7, 5, 1, 8. So this is 17 by 18. Clear? So this will be the given ratio. That should be equal 8 upon 9. So here students see we are taking the ratio which is the. So here correct the data, one value we have written wrong. That's why this CF is given as 8, not 8.5. So this is already 8 is given. So the ratio is 8 by 9. So PF is given 8, RF is given as 9. So now dear student, what we give? Both parts are equal. Right hand side both are equal. So by 1 and 2, we get result what? PE upon QE equal to PF upon RF. So by converse of BPT, by converse of BPT. We can say EF parallel to QR. So in this way, dear student, one can prove the second part. Clear? Now see here, next last part we are given PQ 1.28, PR 2.56, PE is given and PF is given. So we want to find the third, as we need what? QE, that is not given, we want to find, and FR. So that also given, we need PR. So you can find first of all QE. So from figure C, this side QE can be written as PQ minus PR. So PQ minus PR. PQ minus PE, not PR. This is PE. See very carefully, this QE can be written as PQ minus PR. Because QE not given, that's why we have to find for this. So PQ is given as 1.28 minus PE, that is 0.18. So you subtract this. So 8, 8, 0, 1. So 1.10. So this is the value of EQ. Similarly, in the we are need the value of FR. So FR is also not given. So you can find the FR. So by the figure you can say FR means PR minus PL. So this is PR minus PL. So PR is given 2.56 minus PF 0.36. So subtract. So 660, 532 and 2. So 2.20. So now we get all the part. So we have to check the ratio PE upon EQ. So PE 0.18 divided by EQ, that is 1.10. That is 18 upon 110. Similarly, second we see PF upon FR. So PF is given 0.36 upon 2.20, which is 36 upon 220. So dear student, if you multiply this, then you get 36 upon 220. So both are equal. So what we get the result here? In third case, PE upon EQ, that should be equal to PF upon FR. So again by converse of BPT, side EF is parallel to QR. So dear student, in this way we can check. This is very important for 1 mark question. How to check either the given line EF is parallel to QR or not. If we are given the length of the side of the triangle or line segment of the triangle. So using this theorem, we may check either the ratio is equal or not. If ratio is equal, their sides are proportional, otherwise not. Next question, see dear student. In the given figure, we are given figure. This is the given figure. In this figure, say LM parallel to CD. So this LM is parallel to CD. LN parallel to CD. LN parallel to CD. Then you have to prove this result. Very interesting use of the basic proportionality theorem. So solution see here in triangle ABC. So you can see this is a triangle ABC. In this triangle, if you see as given ML parallel to, so in triangle ABC given LM parallel to CD. So as you know that in a triangle, if one side or if one line is parallel to one side of a triangle, then this line bisects other two sides in the same ratio. So what we get? Same ratio is AM upon MB is equal to AL upon LC. This is by basic proportionality theorem. So what says basic proportionality theorem? If this line is parallel to this, then it divides in the same ratio. That is AM upon MB equal to AL upon LC. So we get this result. Now we can consider second one. Also in triangle ABC. So in ADC triangle you can see as given. Here in this triangle we are given what? LN parallel to CD. Given LN parallel to CD. So here also we use the basic proportionality theorem, that is AN upon ND equal to AL upon LC. AL upon LC. Now dear student, you can see equation 1 and 2. By equation 1 and 2 we get. So in these two equations, left side are equal, AL upon LC, AL upon LC. So right side should be also equal, that is AM upon MB is equal to AN by MB. But again this is our not result. What we need? AN upon AB, here MB is given, and AN upon AB, here AN upon MB. So denominator is different. So dear student, you can say this is the part of the AB and this is part of the AD. So part, if you want to complete in the given side AB, we have to add 1 on both sides, numerator and denominator. So the numerator is complete because we want to AM as AM, but in the denominator we need this. So for that you have to converse and then add 1. Otherwise you can change the numerator, or this can be also written MB upon AM, ND upon AM. Numerator and denominator are interchanging, then there is no change in the ratio. Now we add 1 on both sides. Adding 1 on both sides, there is no change in the ratio. So what will be this? MB plus LCM in the left side AM. And right hand side also we take LCM. So ND plus AM upon AM. So now see from the figure, MB plus AM, MB plus AM. So that is complete AM. Can write AB. MB plus ML. We can write AB upon AM. So according to your requirement, you have to change this. ND plus AM. That is AB upon AM. Now again what we need, that numerator and denominator interchange. So if you are interchanging them, AM upon AB, AN upon AB, else. So dear student, in this way we can prove. So this is very important how one can prove the result. As our requirement, you have to change the equation, either interchanging the numerator or denominator, or you have to add 1. Next problem says, example question number 4. In the given figure, we are given figure DE parallel to AC. This triangle ABC, in which this DE parallel to AC. This is given, and DF parallel to AE. DF parallel to AE. You have to prove this. So in solution, we write here in the given figure DE parallel to AC. So in triangle ABC, by basic proportionality theorem, so in triangle DE is parallel to AC. So dear student, you can see in triangle ABC, if one line is parallel to the other side of the triangle, then other two sides are divided in the same ratio. So we can say that BD upon DA should be equal to BE upon EC. So what we can write? BD upon DA equal to BE upon EC. This is equation 1. Also given, also what we are given? DF. DF parallel to AE in triangle ABC. DF, now this side, see very carefully, DF parallel to AE. So you can say either triangle ABC or you can say triangle ABE. So no confusion, ABE. So in this triangle, if DF parallel to AE, then by BPT, BD upon DA equal to BF upon F. So what we can write? BD upon DA equal to BF by basic proportionality theorem. Now dear student, you can see equation 1 and 2. Both have left side equal, BD upon DA, BD upon DA. So if their left hand side are equal, then their right hand side should be also equal. So by 1 and 2, we get result. What? BE or BF upon FE equal to BE upon EC. BF upon FE equal to BE upon. So that what we want to prove. So in this way we can prove the result. So this is the direct application of the theorem basic proportionality. Clear? So now next thing, next question C. In the given figure, DE parallel to OQ and DF parallel to OR, so that EF parallel to CR. So in triangle DE parallel to OQ, DF parallel to OR, then we have to prove EF is also parallel to QR. So in solution given, in triangle, suppose we are considering triangle POQ. In this DE parallel to OQ, then by basic proportionality theorem, suppose we are considering this triangle POQ. In this triangle, this side DE parallel to OQ. Then what says? Basic proportionality theorem, other side are divided into same ratio. So PD upon DO, PD upon DO equal to PE upon PP. This is one. Also in triangle POR, now we take this triangle POR. In this triangle DF parallel to OR, DF parallel to OR. So again by basic proportionality theorem. So what we get? PD upon DO. In triangle POR, DF parallel to OR, then PD upon DO equal to PF upon FR. This is second. So you can observe the equation first and second. So by equation first and second we get what? Both have left side are equal. So right hand side should be also equal. PE upon EQ equal to PF upon FR. Now you can say in triangle PQR, as we prove that PE upon EQ is equal to PF upon FR. See dear student very carefully, in the triangle PQR we are saying that PE upon EQ equal to PF upon FR. So by converse of BPT we get result by converse of basic proportionality theorem that EF parallel to QR. Hence true. So in this way we can prove the result that EF is parallel to QR. Next example, question number 6 is, in the given figure we are given a figure A, B, C are points on OP. This is the OP point A, OQ, B and OC, OP, OQ and OR respectively, such that AB parallel to PQ, AC parallel to PR, then show that BC is also true. So we are given a triangle this PQR and one triangle inside ABC. So say this AB parallel to PQ and AC parallel to PR. Then we have to prove that BC is also true. So again here we have use of the basic proportionality theorem. So you can see in triangle. Now suppose you consider this triangle OPQ. In triangle OPQ, we are given AB parallel to PQ. So by basic proportionality theorem, if in triangle OPQ this side is parallel to this, then their ratio, that is OA upon AP, OA upon AP should be equal to OP upon BQ. Also in triangle, now we take this triangle OPR, we are given AC parallel to PR. So here also we use basic proportionality theorem. So in this triangle OPR, we are saying that this AC parallel to this. So again OA upon AP is equal to OC upon CR. Now by 1 and 2 you can see, by 1 and 2 we get both have right and left hand side are equal. So right hand side should be equal OB upon BQ equal to OC upon CR. Now you see in triangle OQR we have proved that OB upon BQ equal to OC upon CR. Dear students, see in triangle OQR, OB upon BQ equal to OC upon C. So this side will be parallel. By the converse of BPT, so see dear student, here I am taking the triangles OQR and we are taking the ratio, that is OB upon BQ equal to OC upon CR. So by using converse of BPT, by Converse of basic proportionality theorem. What says this side will be, or line BC will be parallel to QR, and that we want to prove. So hence prove. So in this way one can prove the line is parallel to the side of the. Next, see dear student, question number 7 very important. Using theorem 6.1 is again basic proportionality theorem we have to use, and say prove that the line drawn through the midpoint of one side of a triangle. If we are drawing the line from the midpoint of one side of a triangle is parallel to another, bisect the third side. So this is very important. We are given that one triangle ABC. ABC is a triangle. Now say if you are drawing a line from the midpoint of this, suppose this is D. Prove that line drawn through the midpoint of one side. Midpoint of one side means we are taking AB as a one side, its midpoint D. Now from this point D we draw a line which is parallel to another side. Means suppose this is parallel to BC and intersecting E at E for AC, then say that this bisect the third side. Then you have to prove this side AC is bisected at the point E. Means E is also midpoint of the D. So you have already seen in 9th class midpoint theorem that you have already proved. Now we prove using this one. So in solution write, here we are given triangle ABC in which D is the midpoint of AB. Now midpoint of AB means AD equal to BD, and we want to prove E is the midpoint of AC. That is, you have to show that this we want to prove, and this is given. Now as we are what given DE parallel to BC. So by basic proportionality theorem, this is already given. Triangle is parallel to another side. This line DE is parallel to BC. This is given. So we can say DE parallel to BC. Then by BPT we are saying AD upon BD equal to AE upon EC. But by one. So one part say AD equal to BD. This is given. And D is the midpoint of AB. So you can replace AD by BD in this one. So AD replaced by BD upon BD. So what see BD upon BD 1. Now cross multiply. So 1 get. So that we want to prove. Or you can say E is the midpoint of AC. Or you can say DE bisect third side. That problem says you have to show what? Prove that a line drawn the midpoint of one side of a triangle. This is one side of triangle, we are drawing midpoint. Then this drawn parallel to the second side, and it should be, you have to prove that third side is bisected at the point E, or it is bisected by the line DE. That you have to show. Next, that is also similar to previous one, using theorem 6.1. With again you have to use BPT. For what? Prove that line joining the midpoint of the two sides of a triangle. Line joining the midpoint of the two sides of a triangle is parallel to third side. So dear student, you have already done this congruent triangle in 9th class, but here we are using the method is different. So what we are given a triangle. Suppose we are given triangle ABC, and what says prove the midpoint of the. Suppose you have to consider D and E are the midpoints of these two sides, then line joining the midpoint with D is parallel to BC. So in solution, right, here we are given triangle ABC in which D and E are the midpoints of sides AB and AC respectively. That is, now see, D is the midpoint of AB. It means D is the midpoint of AB. So it bisects or divide into two equal parts. Or you may write AD upon BD. Divide both sides by BD. Here we are dividing both sides by BD. BD upon BD 1. AD upon BD. So we get the first result. Now second, E is also the midpoint of AC. So midpoint AC is AE upon AC. Now again you divide both sides by EC. So what we get? AE upon EC. 1. Now if you compare 1 and 2. So by 1 and 2 we get what? Both have right hand side equal, that is 1. It means their left hand side should be also equal. So we can write AD upon BD is equal to AE upon AC. Now by converse, so what we see here? AD upon BD equal to AE upon EC. So you can say in triangle ABC, DE such that AD upon BD equal to AE upon EC. So by converse of basic proportionality theorem says this DE should be parallel to BC. Hence that you want to prove. What prove? Is parallel to third side. Question what says? Prove that the line joining the midpoint of the two sides. So this D is midpoint of first side, E is the midpoint of the second side. Now line joining midpoint with D parallel to the third side with D parallel to BC. So dear student, in this way you can prove that this side is parallel to third. This is very important. Next, dear student, question number 9. ABCD is a trapezium. Means we are given a trapezium. Suppose this is a trapezium. A, B, C, D is a trapezium and its diagonal. So opposite vertex is joined, that is diagonal, intersect at the point O, so that AO upon BO equal to CO upon DO. This we want to prove. So for that, dear student, we have to draw a line which is parallel to the either AB or CD. So for proof of this, we draw FO parallel to AB, or AB is already parallel as given. Trapezium ABCD in which AB parallel to BC. What is the meaning of a trapezium? It is a quadrilateral in which one pair of opposite sides are parallel. So here we are supposing this AB is parallel to BC. Correct? So now we are drawing a line here FO which is parallel to AB as well as BC. So consider triangle ABD. First we consider this triangle ABD. So in this AB is parallel to or FO parallel to AB as our construction. We are constructing in this way. So why? By basic proportionality theorem what says? If this FO is parallel to AB, then this says or construction says basic proportionality theorem DF upon AF is equal to BO upon BO. See very carefully. DF upon FA equal to DO upon OB. Order will be same. So this is equation number 1. Also FO or in triangle ABC. Now we consider this triangle ABC. In this also FO parallel to BC. FO parallel to BC. Here we are writing all three are parallel. So by basic proportionality theorem. So if you see this triangle, then what we get? DF upon FA. DF upon FA. Or AF you can write. DF upon FA equal to CO upon AO. So by 1 and 2, see here this and this, both have left hand side equal, so their right hand side should be also equal. That is BO upon BO equal to CO upon AO. Right? Now see here we have to interchange these values, so that will give you the answer or correct the answer, that is AO upon BO. So you have to interchange the values. This will be interplaced. So DO upon BO equal to AO upon CO. Right? So you can write here this interchanging this ratio may be, so DO upon BO, that is CO upon this one, or you may remain in that way, that is also true. Correct? Because in ratio you can interchange these one, that is DO upon BO is equal to AO upon BO equal to CO upon AO. That we are doing. Right? DO upon BO equal to CO. So in this way, dear student, one can get the answer, or you can also prove that is, see here we have taken one side in not correct order, that's why some problem is there. Like see in the first triangle, yes, order is important, DF upon FA. So you have to take corresponding second will be DO upon OB. We have written OB upon DO. So this correct, then DO upon OB. This remains same. Now you can see in both the left hand side are equal, so the right hand side should be also equal. That is DO upon OB equal to CO upon AO. DO upon OB, CO upon A. Now you can interchange the numerator. So ratio remains same as you already learned in the ratio and proportional chapter. So this AO replace here and DO. So AO upon OB, CO upon D. That we want to prove. So in this way one can prove the diagonals of bisect proportional. Next, that is important, diagonals of a quadrilateral. We are given a triangle quadrilateral ABCD. So diagonal, that is AC and BD, intersect each other at the point O. Now condition is given how they are intersecting, the ratio of these parts are equal, and you have to show that ABCD is a trapezium. So again here we have a construction. We draw a line EO in solution. We draw a line EO which is parallel to AB. We are drawing a line EO parallel to which meet AD at E. Means from this we can draw a line. So this EO parallel to AB. This is our construction. So you can write in the given figure EO parallel to AB as our construction. So in triangle ADB, if EO parallel to AB, then by basic proportionality theorem. So dear student, in the triangle ADB, EO parallel to AB. So what says the basic proportionality theorem, that is dE upon EA, dE upon EA is equal to dO upon OB, right? And this is the basic proportionality theorem. And what is given? And also given AO upon BO equal to CO upon DO. Now you can see here in the given DO upon OB. So in these two you can say either you can interchange again the denominator of AO, because what we need, that is DO upon OB we need. So this can be interchanged. So we get here AO upon CO. This is very important to interchange the numerator and denominator. Equal to DO upon DO. Clear? So what we get, AO upon CO equal to BO upon DO. Now you have to again interchange the numerator and denominator. So what we get? If you are interchanging numerator and denominator, DO upon OB. Now you compare these two. You get that both sides are equal. DO upon OB equal to CO upon OB. So now you can mark this as a equation 2. So by 1 and 2 we get. So what we get here, DE upon EA is equal to CO upon AO. Now in triangle, now you can say in triangle ADC, if DE upon EA equal to CO upon EO. So by converse of BPT, see here, DE upon EA is equal to CO upon AO, right? DE upon EA equal to CE upon AO. So what says the converse of BPT? This side EA or line EA parallel to BC. So EO parallel to BC. But we are given or other construction. So construction what say? EO is parallel to AB. So what see? EO parallel to BC and EO parallel to AB. Hence EO parallel to DC and EO parallel to AB. It means both are side AB is parallel to DC. So one pair of the opposite side of a quadrilateral is parallel. That's why it is a trapezium. Therefore ABCD is a trapezium. So dear student, here we have solved this whole exercise in very easy way. You go for this and make practice, so you get the good marks. Thanks for watching. Next video you see the solution of the next exercise. So have a nice day. Thanks for watching. To be continue with us for more videos.